Hello everyone and welcome to this in-depth exploration of life cycle assessment, or a scientific method to evaluate the environmental impacts of products, processes, or services across their entire life cycle. Today, we'll uncover what LCA really means, why it matters, and how to apply it step by step from theory to practice. Let's start with the fundamentals. Here's what we'll cover today. First, we'll define what LCA is and unveil its core framework through everyday examples. Then, we'll discuss why learning LCA is crucial, from corporate strategy to consumer choices and policymaking. Next, we'll break down the 4 key stages of the LCA process. And finally, we'll walk through practical steps to implement LCA in real projects, including tools and tips. Let's begin with page 1. What is LCA? Our first stop is understanding what LCA truly is. To grasp this, let's start with something familiar: the concept of a life cycle, which we encounter every day. Take your smartphone as an example. Its journey begins with mineral extraction, getting raw materials, moves to factory manufacturing, then logistics transportation, followed by daily use, and finally waste recycling. This complete journey is what we call the life cycle of a product. An LCA is designed to evaluate its environmental impacts across every single stage of this cycle. So, what is life cycle assessment? LCA is a systematic method used to evaluate the environmental and impacts of a product throughout its entire life cycle, from the cradle when raw materials are extracted to the grave when it's disposed of. This includes all stages: raw material acquisition, production, transportation, usage, and final disposal. It's a holistic approach to understanding environmental cost. The core principles of LCA are critical to remember. First, it focuses on the entire cradle-to-grave process, not just one isolated stage like production. Second, it emphasizes system thinking, meaning we analyze how all stages are connected. To avoid problem shifting, for example, reducing emissions in production might accidentally increase them during transportation. LCA helps us see the bigger picture. Let's briefly look at the origins and development of LCA. The concept emerged in the 1960s when global environmental issues became more prominent. People started realizing that products impact the environment not just when we use them. Over the following decades, it evolved from academic and research into a standardized tool, formalized in the ISO 14040 series of international standards. Today, it's globally recognized as a reliable method for environmental impact assessment. In modern times, LCA has taken on even greater significance. Driven by goals like carbon neutrality and sustainable development, LCA has become an essential decision support tool. It's used by corporations for green transformation, by governments for policymaking, and by consumers for making greener choices. It's no longer just an academic concept. It's a practical guide for sustainability. Now let's introduce some core LCA terminology that beginners need to know. First up, the functional unit. This is the balance weight or reference point for measuring a product's or service's function. For example, it could be 1 biodegradable plastic cup, 1 kilometer traveled by a vehicle, or any other defined unit. The functional unit ensures that we're making fair comparisons between different products or scenarios. Next is the system boundaries. This defines which stages of the life cycle are included in the assessment. For example, do we include the transportation of raw materials? What about energy consumption during the product's usage phase? The boundaries you set will directly influence the results. Different boundaries can lead to different conclusions, so it's essential to define them clearly, transparently, and reasonably. Finally, environmental impact categories. These are the specific environmental issues that LCA evaluates. Examples include global warming caused by carbon emissions, resource depletion using up minerals or water, water pollution, ozone layer depletion, and more. These categories are the focus of our assessment. They help us understand exactly what environmental problems a product might contribute to.